Well, good morning, ladies and gentlemen. Please bear with me, I'm still trying to wake myself up. But today we're going to do something a little bit different. Generally, when we've done this training for chemistry, we've dealt with what we call hazard communication. I saw you for biology the other day,
Yeah, I
right?
had bio training yesterday.
Yeah, well, you're going to see a little bit of a different presentation today. So what's going to happen is more administrative work for y'all. But what this is going to do is, since we are not really giving you hazard communication training, which is a federal and state requirement, I want to ask you to fill out the sheet. And what we're going to do is a lot of our training is going into the SAP system. It's online training. So by signing this, basically we're going to, eventually you're going to be doing hazard communication training, getting in compliance. Right now, we're breaking law. So I don't know you, you don't know me. As I'm going along, if I can be going too fast, or if you have some questions, please raise your hand. Or if you want to pitch in a little extra information, I'm all about group participation. So we work with the safety office. You can see we've got a real nice long title to our name. I can't say it in a heartbeat, so I always say safety office or safety inspectors. And as we go through, if you have any questions or down the line during the semester you've got to deal with an issue, basically we have a part of Texas State's website. All you got to do is punch in safety, risk management, workers' comp. That's what anything that have to do with potentially safety issues, you're going to get this to pop up and you can work yourself in from there. And so, kind of doing a little HAZCOM here for you. The goal of our office is we do training to try to stay compliant with state and federal regulations. There are rules that say you've got to learn about safety. Sorry. Being safe is a little dry, but it's something we've got to do. The other thing is, one of our primary goals, or the primary things we do, is make the university aware of the hazards around you. And so it's kind of like a chain of command. Basically, pretty much everybody in here is a TA. Am I correct? Yes? No? Maybe so?
Yes.
So basically, you are responsible for your students. And our office is kind of responsible for the people on campus. So what I'm doing is, what I'm trying to get to you is, when you teach your students, when they come in that first day, you are obligated to tell them about the hazards in the lab. Well, what I'm doing is kind of light you up on looking around for hazards in the lab. And so y'all are the experts when it comes to chemistry. You know that stuff better than I do. So they're going to need those young minds full of mush are going to need your help before they need mine. And so talking about hazard communication, jump the gun, we're going to hear the word right to know. If you walk into a situation that's full of hazards and your boss says get to it and doesn't tell you about those hazards, he's breaking the law. It is your right to know about hazards in the lab. It is your students' right to know about hazards in the lab. If they've never worked with sulfuric acid or dilution thereof, it is your job to tell them what you can do, what you can't do. You can't put it in your coffee, you can't put it on your cornflakes. That's your responsibility to tell them. So we're trying to prevent injuries, is what we're trying to do. The other thing, we're trying to prevent loss of equipment. Like I mentioned in the class the other day, for biology, we're an emerging research university, and that's mainly because of you and biology and the call of the engineers. Because y'all's hard work, we attain that status. Now we're shooting for, was it tier 1, tier 2? So we're getting more and more known for our research, the work. So congratulations to you all. But the point being is, if you're blowing up a lab, either a teaching lab or your research lab, so much for emerging research, it's more like emerging problems. Preventing injuries, you can't do research and your students can't graduate or get a grade for their class when their face is all crusty or their hands are all crusty. That doesn't help them. It's kind of hard to write when you're all messed up. We're trying to prevent injuries. The safety office and UTA should be trying to prevent injuries. So at the same time, you got to think of yourself, think of your students, think of everything. So how do you protect yourself and control the hazards around you? So being prepared. So each other going to be dealing with what, maybe 15, 20, 25 students maybe? So it's going to be a lot of things going on in your lab. Very dynamic situation. And so you're pretty much running the show, I'm assuming. You've got to be ready for just about anything. While you're sitting there teaching these young minds full of mush, you've got to be kind of vigilant as to what's going on with these kids and how they're doing things. Are you ready for it? What's your procedure? If someone knocks over a beaker, it smashes on the ground, you've got a spill, a broken glass, or whatever. Do you know what to do? Do you have a plan? So it's all about something I want to kind of beat into you. It's all about communication. Everybody talking to everybody. You've got a lab coordinator. You've got the stock room, Rachel Bauer, and her group. You've got yourselves and the other TAs. You've got to talk to each other. It's all about teamwork and being ready for something to have happen. And also, in terms of communication, you tell your students if something breaks or blows up, if someone drops like a sack of potatoes on the ground, there's a procedure. Either everybody stops and waits, or there's going to be a procedure as to what the class needs to do. Especially when, and something We did a little bit a few days ago, dealing with safety showers. There's a lot of things you have to think about that can potentially affect you in a law type of way. I'm saying that right. So aside from you talking to your students and your professor, your major professors talking to you about hazards, here's another way of learning about hazards, posting signs. If a student goes into a lab and doesn't see any safety signs, they should be thinking about themselves like, do I need to be wearing safety glasses? You know, do I need a coat? Or can I wear flip-flops? If you don't have signs in there, you're not warning them about the hazards. And so therefore, you're taking away their right to know. And it works for you as well within your own lab. And so what you're going to see here as well is I'm going to be talking about teaching labs and research labs, kind of flip-flopping. So hang on, stay with me. Again, signs. So chemicals. I know that Stockton deals with most of the chemicals in your labs or preps your solutions. At the same time, you still need to be vigilant about what's out there in your labs. If we're setting chemicals out, one of the main hazards, or how to determine a main hazard, is what's written on a bottle. Whether it be one of these chemical bottles or an algae bottle. It needs to be labeled because that tells you what hazard is present. You see this metal bottle right here? Basically, it's giving you no information whatsoever. And so that is not a good situation. Another example here, we got some type of acid, but we have no idea what type of acid it may be. In terms of communicating, NFPA fire diamond, this is one of the things like for your students, either in research labs or teaching labs. This is something you may see on a chemical bottle. With a series of numbers and letters, basically you can get a lot of information just like that. And something I want to make you aware of, even though we're not really going to do folks on hazard communication, is with the NFPA fire diamond, it's got a scale of 0 to 4. 0 being pretty much harmless, put on your cornflakes. 4, don't even think about doing it. So 4 is bad, 0 is good. What I'm going to do is throw you a curveball here in a second. So, but this is what, more often than not, you're going to see this. But there's a change in the system we're going to talk about in a second. And you've got to have your head screwed on straight when you're trying to learn about the chemicals you're working with and teaching your students. Hazardous materials information system, same thing, the same scale, 0 to 4. 4 being super badass, 0 being, hey, it's all right. Also, you get a little bit of extra information on here. This is what I'm talking about, the global harmonization system. What do you think about when you think of harmonization or harmony? We think of everything falling into line, perfect synchronization. And so what they're doing, and this is something that started up quite a while back, and it was a brainchild of the United Nations, is right now, the global harmonization system, you're starting to see the effect of it a little bit. You see in the old way and the new way. You'll see what I'm talking about here in a second. So the grand scheme of this is, you've got chemicals all over the world, and they all have certain types of hazards. So how do you relay that information to everybody? Different languages, different ages, intelligence, whatever. Remember how that phrase, right to know. With global harmonization, it's a right to know and a right to understand. And so what they're doing is, we've got several different styles of labels out there right now. What's going to happen eventually, supposedly by 2017, it should be pretty much in full blow, is no matter what chemical company makes it, no matter where in the world, the label is going to be the same. You're going to have certain types of characteristics. So here's the deal. We talked about 0 to 4 with NFPA, 0 being not bad, 4 being bad. Well, with the global harmonization system, it's exactly the opposite. And so if someone says, well, it's a category 4, well, you got to think to ask, is it global harmonization or is it NFPA or HMIS? You say, why do I care about this? Safety data sheets. So, one of the things is to protect yourself from hazards and inform your students of hazards. One of the big things, aside from your lab coordinator and the people in the stock room, safety data sheets. We're working with sulfuric acid. I don't know squat about sulfuric acid. It's an acid, that's about it. So someone goes check the safety data sheets, or material safety data sheets. That's what they're called now. So if someone says MSDS, they probably should be saying SDS right now. But basically it's a dossier on the chemical that you're using. And more or less, when you read MSDS, it's going to have all kinds of useful information on it. As TAs, some of the more important things is hazards identification. Tells you what kind of hazards a chemical has. Is it corrosive? Is it flammable? That sort of thing. First aid measures. If someone decides to take a quick shot of that sulfuric acid, do you know what to do if they ingest it? That's going to be in your SDS. Handling and storage. Do I need to wear gloves or can I just use my regular hands? Even more important, where is it? Oh, exposures and controls, personal protection. If someone pours it on their arm, it tells you what to do in terms of do they need to be safety shower or are they good? So very important piece of information. Well, so what's going on is we got material safety data sheets from the old system and safety data sheets with the new system. So let's go down here. We're looking at skin corrosion. Category 1, this is GHS. Category 1, is that good, or is it severe hazard, or is it a slight hazard?
There you go.
Category 1 is a severe hazard with the GHS system. You're looking at a safety data sheet. They're going to the new global harmonization system. This is, I got muriatic acid here. And what I do is now we're going into, this is muriatic acid again, but look, MSDS. This company hasn't shifted over to the new scheme yet. And so they're using the HMIS to the FPA. And so you've got a health hazard of 3. Is that high, or is that severe hazard, or a low hazard? Severe. Severe. Everybody say with me, severe hazard. Severe hazard. So with global harmonization, it says 1. What's the hazard severity? Severe. You got to see where I'm going. So if you decide to go and check out safety data sheets, or you need to recognize what you're looking at, because we're using 2 different scales. If you're not thinking about it, that could work into a very bad situation. So when you look at this stuff, you look at these sheets before you mess with the chemicals. If you don't know about it, and you're working with it in the lab, how are you going to portray the information to your students if you're not quite sure what the hazards are? So it pays to look at something, but look at the sheets before you read the usually chemical. Chemical storage method, and like I said again, with the teaching lab, I don't know how much you're handling chemicals or dealing with it, but it's a place for everything and everything in its place. So if for a period of time you're going to have chemicals in the lab, knowing whether it's flammable or an acid or a base, the idea is keep your bases away from your acids. Even if they're dilutions, just get into the practice, because that's what you should be doing in your research labs, segregating your chemicals. And basically this looks needed. We've got a situation here, we've got all kinds of hazards. No labeling, no organization system or anything. You've got acids and bases and a flammable all on that one table. That's flooded with disaster. Another example, basically, either in teaching labs or whatever, just be careful when you store chemicals if that situation comes up. So, routes to chemical hazards. Why are we talking about safety and that sort of thing? You're dealing with a lot of students who basically don't know how to handle chemicals. One thing you need to pass along to them is, like, why am I wearing gloves? Well, you can get exposed to chemicals through the skin. Or why am I wearing, glasses? Well, you don't want sulfuric acid in your eyes. Why can't I eat a Snicker bar in the lab? Well, you could be potentially ingesting chemical particles. So personal protective equipment, and every lab is different, every situation is different. Like I said, looking at your safety data sheets, it will tell you what kind of personal protective equipment to have. And so it may be just, in some of your teaching labs, gloves at the most. Well, in your research labs, you may be suited up like, RoboCop. So it's something where you gotta, understand what you're working with and understand what you need to use to protect you. It's the same thing. Pass that along to your students. Make them understand why am I wearing these goofy eyeglasses. Personal monitoring. And this is a thing where if you're in a teaching lab, you need to keep an eye on your students. Kids are stressed out, they're doing squirrely diets, they're coming in hungover, who knows what's going on. And so you may be doing your lab and everything's cooking like gas, and someone drops like a sack of potatoes. Then you've got a situation. But basically, if you're trying to keep monitoring your students, you may pick up on something before our situation gets more exaggerated. Or with yourself. You may be handling most of the chemicals for your students, and you're working under a fume hood, and all of a sudden you start feeling kind of dizzy. Where a few seconds ago you felt fine. You gotta think something is up. The fume hood's wrong, or I'm not wearing a certain part of, I forgot to put my respirator on. Think about what's going on for yourself and others. And if something gets, if you see several people affected, it's like get them out of a room, get your lab coordinator, talk to the stock room, talk. If something's not quite right with you or one of your students, go grab another TA next door. You gotta think about communicating. They may be busy too. Work up a system of trying to communicate. Like an emergency response team. Engineering controls, in the teaching labs, probably the main one you're going to look at is fume hoods. And so basically, if you're going to work with if your students need to work with a chemical under a fume hood, tell your students why. It's like, well, it's cramped, it's crowded, I don't want to, do this. Well, basically, the fume hood is pulling the hazard of that chemical away from them. So if you have a student working on a countertop, you say, I need you to work in the hood with the chemical. You turn around, they're sitting on a countertop working with that chemical. You need to jump on them and say, hey, get squared away and get back into that hood. Or, they may get a snorkel full of something, and next thing you know, you've got a problem that you don't want to have. Hey, Elsie, you want to talk about fume hood maintenance in terms of signage and stuff like that? Ladies and gentlemen, this is Elsie Amana, one of our safety specialists, and she deals with fume hood maintenance.
I have a couple of signs that I just wanted to make y'all aware of, because we do maintenance on the electric shop does maintenance on the exhaust fans twice a year in the system. So if you ever see one of these signs, that means the hood is not operating, so don't work under the hood. So it's not drawing. So till the signs are removed, that's when it's safe. Another sign is our student workers, they come through and they check for airflow. And if you also see a sign like that, that also means that it's not safe to work under the hood. So we just wanted to make y'all aware of signage for fume hoods.
So again, with the signs, it gives you a whole bunch more information than you would have if you didn't know. That'd be pretty loud if you're working with a pretty toxic chemical step into a hood and someone to move the sign away or it wasn't signed. Now you're working a fume hood, it's not doing anything for you. That's bad news bears right there. Safety equipment. So think about this, you're dealing with a lot of kids, a lot of students, 15, 25, 30 students even, you. But get an idea of what location of where your safety showers and your eye washes are. So if something happens, bam, you're Action Jackson, you're making something happen, taking care of the student. Know how to use it. Like with the eye washes and the safety showers, 15 minutes, at the least 15 minutes. Again, you have to assess your situation. It may be something where like, hey, I poured this on my arm. Well, they can stick their arm in the sink. You got to know what the sinks are. Do the sinks work? But assess the situation. If someone gets a bunch of stuff splashed in their chest, that's safety shower. There's a whole bunch of conditions in terms of using a safety shower. Check monthly. This is an old. I never took this out. We do have our students. They do check the eye washes right in the showers. But some of them, the way the plumbing is, they can't check them. So when you start a lab for the week, and they only do it monthly, and what we're seeing, Elsie and I were over here checking on some showers and eye washes, or a shower and eye wash. And I don't know how long it had been since it had been flushed, but we pushed that plunger on the eye wash, and I guess for like a minute or so, it was brown water. And so I don't know who wants brown water in their eyes along with sulfuric acid. So one of those things is when we talk with the stock room, I noticed that on this first floor, a lot of these eye washes have buckets underneath them. And so you can kind of do a flush yourself. I mean, again, you're kind of that front line in terms of safety. You're the TA. I'm way across campus, safety office. I can't come help you. We try to do what we can, but a lot of times it comes down to you. Laboratory security, not so much in terms of teaching labs, but research labs. And I'll mention a brief story of an incident that happened a couple of days ago. Even if you're teaching lab, if someone walks in, suppose I'm assuming you're going to have your kid with glasses on at the very least, goggles, glasses, and maybe gloves. So if someone comes in, they may or not be one of your students, but they got nothing on. Hey, what are you doing? Who are you? Glove up, glasses, hands, glasses. With your lab, between your research labs, keep the doors closed. I know it's convenient to keep them propped open, you can come in and out, but there's all kinds of crazy folks wandering around these days. You walk into your lab, oh, look, there's an old apparatus set up. What does it look like? It's smashed. And they'll trash it for you. Crazier things have happened. Something to think about. Hazardous waste, kind of getting into what you do, where you do it. I know that the stock room, Rachel pretty much oversees hazardous waste, but at the same time, you're the one who has students putting hazardous waste in the containers. You can also help Rachel out in terms of making sure that this is one of our standard waste containers. The majority of the containers you use in your labs, teaching labs, is this one. You need to make sure it's got a label on it. I know she has a lot of pre-printed labels and stuff. She's got student workers. Sometimes people get in a rush or just people make mistakes. You need to make sure that's got a label on it. And make sure that, if this one's for sulfuric acid only, make sure that your students understand that. If they mix up these containers, what it does is we dispose of this material at our cost. All this stuff, we do this for y'all for free, and we pay for it. If we mix up waste streams, then our costs go through the roof, depending on what some labs are using. So keep in mind, it's like, yeah, the stockroom's got it, but again, you're helping them out, you're helping us out, looking for labels and making sure they're properly putting the waste where it should be. So chemical waste, anything just think about it. Think about hazardous materials. Actually, I think about the lead in our story here in a second. Also, we provide broken glass boxes, which I've seen pretty much one in every one of the teaching labs. Rachel has these in the storeroom, so if you need one, we provide the boxes, but we don't throw them away. That's up to the chemistry department, the students, the researchers. One thing that I've noticed that's bad in teaching labs, that is not a trash can. It's not a trash can. There was one, I don't know if it's still there, but there was one in one of the teaching labs where basically gloves and paper towels are just keeping out of it. That's a housekeeping issue. That's a potential hazard. As you as TAs, you got to think about that. Well, how do I deal with it? Go to Rachel or talk to a senior TA. What do I do? How do I get a box? What do I do with this box? They should be able to tell you. And if they can't, they can drop a line to us and we can give them all kinds of wonderful information. Do not, one more time, do not, everybody say it with me, do not.
Do not.
One more time, do not.
Do not.
One more time, do not.
Do not.
Thank you. Do not pour chemicals or hazardous waste down the drain. What was it, Wednesday, Thursday, or Tuesday? Somebody up on the 3rd floor, we got a report of a mercury spill. The professor said it's more than you might see from a broken thermometer. And so we went with it, we went and responded, he already kind of put some sulfur powder on to kind of mitigate the situation. It was in a sink, which was not a good thing. He's like, it's a lot. I'm like, okay. So what happened, me and James and I, we ended up spending most of the afternoon cleaning up the stuff in the sink. And the question was, as we asked around, we had UPD up here, we're asking around. It's like, does anybody know who owns this lab and does anybody know who spilled it? Ladies and gentlemen, accidents happen, things happen. We are here to assist you and provide spill response or whatever. Stuff happens. That's all right. Do not be afraid to report something. One time we might start getting onto you is you do it once, okay, this is what you do, don't let it happen again. We come back to your lab and you've done it again. All right, what's going on? And we need some training or something. You do it a 3rd time, then we start talking to your bosses and rattling cages. And right now the thing is, no one fessed up to the mercury spill. So basically, I've been told, I don't think we're still kind of doing some things, but given the amount we found, if it was a little bit worse, it could work into some type of law enforcement situation. And so, dumping chemical down a sink can cause all kinds of trouble. We end up pulling a pound of it out. Almost a half a cup full.
Thank God for P-traps.
Yeah. And so basically, we pretty much deduced that there was no broken containers or empty bottles. And so we're assuming someone came in and just dumped it, which is they're not thinking, or they're, like I said, in terms of security, someone's looking to do something bad. They can walk into your lab and dump mercury down the drain. Next thing you know, it starts this case, and like you're taking the hit for something you didn't do. Think about lab security.
Hey, Chad, one thing to add, the city has multiple testing ports around the university. They test all of our wastewater. So don't think you're gonna get away with something.
Well, and that's right. In my old building, when I was with biology, the Freeman Aquatic Station, one of the labs was discharging, they tested it, they picked up some metal. I can't remember what it was, but they were on the building like locusts. I mean, city inspectors, and they're like, hey, you don't pull your stuff together, we'll bring in Texas Commission of Environmental Quality, the big boys, the EPA of Texas. So think about that. Like I said, accidents happen, but it's all about education and informing yourself. Don't be putting mercury down the drain. Do not do that. Waste containers. Especially for y'all, when those labs get busy, you need to try to keep those lids on those containers, unless you've got kids doing transfers. I've seen sometimes where I've done waste inspections, I do waste inspections. And so I'll check these labs once a month. There have been times where I've walked into a teaching lab and I'll see a funnel sitting in a cardboard. That's what we call those things, a cardboard. It needs to have a lid on it. If by some rare chance someone from TCEQ was to come by doing an inspection, and they do it, is I've been told they could result in a fine of about $5,000. Well, the safety office is not paying $5,000, so someone's going to lose a few grand. And so be mindful of that. Again, a lot of times, like, it's not very consistent. So I'm like, I'm generally yes, sir.
So in the vent hood, the funnel is okay? Is that
No, unless the labs are just buzzing. You got people coming in like a line of people dumping in. But if it's slow, or you got 1 or 2 students, I'd say keep the cap on. I know it's a pain in the butt. I mean, judge the situation. Just be aware that if an inspector like Shay was to walk in or I was to walk in and see that, you might be ready to go, like, hey, I've got a busy class, that's why that funnel's there. We may roll with that, it just depends. But when the lab is over, at the very least, when the lab is done, make sure the caps are on there, at the very least. Also, again, I know the stockroom deals with the waste primarily, but you can help them out by monitoring these labels. Rachel does, her group does a really good job at how they position the labels, so they don't get splattered like that and, unable to read. Because what we have to do is we take that waste, we have to classify it. And if we can't read the label, for one reason or another, that causes problems for us, and our cost to will go through the roof. So help us out. Broken glass boxes, just remember if they fill up, talk to the stock room, say, hey, can we get one changed out? And again, if they don't know how to deal with it, they can always call us, or y'all can call us, we're more than happy to help.
Hey, Chet, where do they dispose the broken glass? Y'all know where to dispose, or how to handle it once it's filled?
There's a dumpster around the corner behind the building.
That's what I wanted to make sure y'all understand, because you can't just leave it there for custodial staff, nobody will, so every lab is responsible for your own broken glass. And make sure it's not contaminated with any biological, radiological, or any other chemical material.
And that's the other thing, is like, if the box is overflowing, just by chance, no one's managing it, get someone to help you. If you got a bunch of glass, generally, when these things are about 3/4 full, twist ties, or at least got little ties on them, tie the bag in, push it in the box, tape up the box into the dumpster. But if it's overflowing with stuff, that's a hazard right there. You gotta think about how to handle it, get some help.
And label it broken glass.
Yeah, that's the thing, if someone is dumpster diving, they see a box all taped up, like, hey, this is awesome. Next thing you know, they're got a face full of glass pipettes or something, that wouldn't be good. You get that, you get Elsie?
Yeah.
Chemical spills. And again, assessment. Small spills, big spills. We consider big spills like 5 gallons, but even a 1,000 ml beaker or something splashing the floor, that's a pretty good sized spill. That's something you guys think about. Is it minor, is it major? You gotta decide. Make an assessment. Have a game plan. Again, this is about communication between the stockroom, the other TAs, the lab coordinator. It's all about communication, building a team, setting up a system of dealing with issues. And so, once you decide it's a small spill, well, I know what it is. Again, knowing what you're working with, dilutions or full strength, whatever. It may be a paper towel and I'm good. Or it's like, oh crap, we need to get home some baking soda. Or, oh hell, we gotta get the hell out of the room. You gotta assess it, think about it. Communication, notify the stockroom, notify the other TA, especially if you're bailing out of a lab, let other people know what's going on. And again, the heat on the side of caution, if you're just not sure, it's like, oh shoot, 911, bring in the cavalry. Better play safe than make a mistake going, I don't want to bother anybody, I don't want to get in trouble, whatever. Don't let that be a factor in your mind, how you your decision tree and how to deal with issues. If you do deal with a spill, there's a whole process you want to go through. Understand how to clean it up. Use the right material. Protect yourself. And again, think about while you're cleaning up a spill, what is your class doing? Because now you're bending over cleaning up this spill. Do they understand what to do? Or like, keep working? I want everybody to stop. I need to clean this up. That sort of thing. Because while you're cleaning up the spill, people may create another hazard by you not monitoring. You may have a rowdy class or something. Like I said, protect yourself. If you're going to clean up a spill, even if you have to use one of our spill kits, you got to clean it up good. Don't just leave pads on the ground or paper towels on the ground. Especially if it is a hazardous material, you got to bag it up and tag it. Tell Rachel where to dispose of it. You can't just be throwing stuff in the dumpster for kids. Just outside the door here, we got one of our spill kits. You're like, hey, I don't want paper towels with sulfuric acid. You read the SDS sheets, that doesn't work. I need something else. I need the neutralizer or whatever. We got the spill kit right outside, and we inspect them every month, try to keep them stocked up. You've got booms with socks, so if you've got a flow going, you can use the socks as a dam. So you're throwing down pads, using the booms to block flow. We've got gloves and goggles. Protect yourself. Think about yourself. You've got some instructions in there, box of baking, so you can kind of deal with a number of things that we'll provide you. So if you see a yellow bucket, it's got good spill kit stuff. The emergency service area. For any type of injuries, or if you need help or whatever, firefighters, call the fire department, that's just outside there. That's where they're gonna show up, right, Jimmy?
Yes, sir, just down the hill. If you go out, it's around these steps and down the corner. That's the emergency service area because when you call for help, you're always gonna get UPE, probably fire, and probably EMS. So they all need a place to park. That's the best place for everybody to go. So when you call for help, go meet them there. Take them up to where the problem is. You'll get help to your people faster, I promise.
Thank you, James. This is James Fry. He's our fire marshal from the safety office. So if anybody knows, that man does. Injuries. Basically, in terms of injuries, we're kind of doing a little dancing around here. We're talking about thinking about workers' comp. More for like you. In terms of workers' comp, if you're an employee, TAs, if you get hurt, we'll have some information you need to take some steps. Or if one of your classmates or your students is an employee, there's some steps they gotta take. So if something happens, someone gets hurt in some form or fashion, you need to report it as soon as possible to your supervisor. Anybody, everybody, it needs to go to a higher up. Because basically there needs some paperwork. There's going to be a comp plan. The paperwork needs to get rolling. What you'll do is they'll call our office for the forms. Unless your supervisor should have the forms on hand. They should start filling that paperwork out and get it sent to our comp specialist, Diana Reyes. Call our office and they'll put, say I'm going to do a workers' comp deal, and they'll put her in touch with her. Let's see what else do I got here. Lab injuries. What are you going to be dealing with? Anything from cuts, burns, people passing out for one reason or another, chemical exposure. That's just some of the things that can happen. And again, if someone comes up hurt, and again, tell your students if they get hurt, a little scratch or whatever, a little drop of chemical on their hand, tell your students they need to communicate to you that they've done something. Don't have them worried about getting in trouble. And so if someone goes up, I just spilled some stuff on my hand. It's an injury assessment. You look at it and go, what was it? Well, it was, 2% sulfuric. Okay, well, let's get your hand under the sink. Know what you got to do. Again, think about the SDS sheets or material safety data sheets, whatever you may be looking at. What does that information tell you how to treat with it? Is it major? Again, if someone gets splashed all over their chest, now what are you doing? Well, safety shower, pronto. And like I said, there's some things to think about that there. And also, you're dialing 911, communicating. Let's stop her number. Now you've got to call into Calvary because you got someone under a safety shower for 15 minutes. Let's see. And just kind of just for a illustration, we got a couple of pictures of burns. This is the first big burn. This is not a first aid class, which we do provide first aid classes, right, James? Mm-hmm. So this, put her in a stream of cool water, something like that. But something like that is you're calling ambulance. If the student's saying, no, I'm fine, no, you're not fine. Yes, ma'am.
God forbid you have to have a student use a safety shower. What do you do with all your other students?
We're going to get to that. I love it. Perfect. You're thinking ahead. So, let's see. Safety shower, exposure. Eyes and body, that's what you're worrying about. We're going to get into talk about the safety shower right now. So Elsie, Romano, and I, we were going to actually have a section where we have some of you kids check out the safety shower in action. Have somebody actually underneath it. Well, that didn't quite work out. But while we were running this situation, what I did was, Elsie's like, well, I need to see what it looks like for somebody in their safety shower. And so I volunteered. I got my clothes on. I don't care. So I got underneath the safety shower for about 2 seconds. And it works really, really well. So, but, again, I just said, let's give you a clue. I said I was what? Fully clothed. Well, if I got stuff all over my chest, what's the first thing that's going to have to happen? They're going to have to start doing a striptease. Everything's got to come off. Everything's got to come off. Shower don't work if you got clothes on. And so, which brings up your question. Now you've got a class, someone's just had just a bad spill on their chest, you push them to the safety shower. Well, has anybody ever noticed where the safety showers are located on the first floor here?
Right in front of the door.
Right by the entrance. So, you've got two things to think about. Now I've got a student who's freaking out, and you're freaking out, and you got kids watching. And so, And something else he showed me is like, with all these rooms, you can get in the room other ways, like a bailout. Other doors, you can go cross over into another lab. So something you gotta think about, if someone has a situation like that, you have a class like, I want everybody to bail out. Give a, emergency for it or whatever, and they need to know how to get out. And you can't be sitting there going, go over there, lead them out, you still got someone who, needs to be under the safety shower. And you're saying, well, why can't I have my students in there while I'm doing this? Well, what's the first problem? You've got what under a safety shower? You got a naked person. And what's one of the things that something that drives me nuts these days? I'm starting to love technology, but what do people have a tendency to do when stuff happens?
Video.
Break out the phone. Hey, check this out. Now you got a student videotaping a naked student in a safety shower. Now what are they gonna do with that footage? Hey, Facebook, whatever, check it out. You gotta think of it, because now it becomes an issue of law. This person, finds out they were videotaped or something, or just having people watch her, she can make, cause all kinds of trouble there. So think about that. Another thing, I only was in the shower for 2 seconds, and I was clothed. What's the first thing I said as soon as I pulled that chain?
It's cold.
That water is ice freaking cold. So think about being under a shower for 15 minutes naked. What's possibly going to happen to this person? They're already freaking out. Their skin's getting burned, and now they're freezing. And they're going to sit there for 15 minutes in ice cold water. What do you have to think about then? Hypothermia. So that's all kinds of fun in there, right, folks? So that's the thing. And you can see, keeps talking about hazards and knowing what to do and plans and stuff like that. I mean, I'll be honest, I really hadn't thought about it in taking a shower. It's like, holy cow, there's a whole kinds of factors in there. So a couple of things here. I think I'm doing pretty good on time, so I want to kind of elaborate on this a little bit more. What can I do with your class? There's some things you can do to, like there's no curtain in the safety shower. Let's say you can't get your students to bail out for one reason or another. What you can do, again, if you know one of the students, or if some sort of plan where you have a helper, it's like, hey, I need you to do this and handle this while I'm doing with this. In terms of being discreet, you've got someone in your safety shower who's naked. Well, how can I keep them covered up? If I can't get the class to bail out, what you can do is basically like, let's say this stool is the person. What you can do is have people stand with their backs to them and basically form a circle. And so you've got some type of a screen. So you're trying to give them some sort of, I can't think of the word, but keeping them covered up. Sorry? Privacy. Yes, ma'am.
I think most of the labs have a fire blanket, and it's not huge, but that might help in this situation, just to have a visual block.
Excellent idea. But that's the thing where, in your TA, I don't know if you, TAs get together every week for meetings, I don't know if they do that or not. But it's something to discuss, like, what's our plan if something like that happens? That's the sort of thing. And again, the other thing to think about is, even with the safety showers, one of the things I noticed was, we did a little quick test of it. We didn't have full open, we just want to see what it was like. And the first, about 10 seconds, just let it dribble out. What color was the water? Brown. So again, when it comes to flushing, our office tries to do that stuff, but again, you're on the front lines. You're there more often than we are. So maybe setting up a system, a flushing system. I think Rachel Bauer says they do it, but I have no idea what the frequency is. The other thing I noticed too is I had that shower going, once I got done, I was covered with these flecks of calcium. So you got to think about the person, you don't want them looking up into it or whatever. You got bits of debris coming out of that shower. And so that might be get something in their eyes or whatever. So probably not so much a big problem, but something to keep in mind. With the Eyewash, same thing, 15 minutes. Hold their head into it, open their eyes, pry them open, nail them open, staple them open, whatever you got to do. But 15 minutes. The other thing to think about, again, a friend of mine had a couple of times, got some issues with her eyes. Same thing with the safety shower. You've got to think about the person. Forget the property. You're thinking about the person. And so with the safety shower, yes ma'am.
What if you have contacts on?
Do the best you can to get them out.
You don't want to touch your eyes though, right? You just want to try and flush them out, right?
I'm sorry?
So you don't want to touch your eyes though.
No, basically you want those water streams in the eyes. You got them, doing this sort of thing. So yeah, don't be poking jamming your finger in their eyes if you can help it. But do what you got to do. Eyewashes and showers, 15 minutes. That shower, if you run that thing for 15 minutes, this whole floor is going to be flooded. Are you worried about that? No. Are you worried about that?
No.
Same thing with the eyewash. And again, thinking about a plan. You want get your class out there before you start doing an eyewash. And have them go lab to lab, like, hey, this whole freaking floor is about to become wet. And now you got, you could have a potential slip hazard. So I mean, think about that. But if you're thinking about that person freaking out, get them cleaned up, 15 minutes, no less. Again, to communication, talk to them. Talk to Bauer, talk to MJ. Communicate, let people know stuff's going on. And again, if you do the safety shower, even the eyewash, who are you calling? 911. And James, in terms of someone in a safe shower and eyewash, do you want, if they make that call, do you want to try to direct fire department to the room, or you taking the person out?
It's always, it's better to leave it in the room and go meet the fire department or the EMS and tell them what you got. Because they're gonna know, especially an ambulance, because they have a lot of equipment, they know what to bring. We had somebody that was exposed to this, and they'll know to bring, that type of stuff in that box. Otherwise, they're gonna load up the gurney with everything. The medics rotate a lot. It's a career that doesn't have a lot of longevity, so there's a lot of turnaround. I try to keep them educated, but they may not know where the elevator is. So this is not the easiest place to find if you're not familiar with this building. So it's always good to go meet them and take them to where you need to go.
So again, it's a teamwork thing. While you're taking care of the student, you need to get someone to go, hey, dial 911 and do this. And go out to the emergency service area. There's a lot of coordination. Any questions, any concerns, comments, criticisms? Yes, sir.
Would it be a good idea to have the student get another TA or have the student wait outside for fire safety to come?
Yeah. I mean, that would be a
Have
way
them
to
take
do
it
it.
in the classroom?
Let's see. All right, so this will be our last section of training, will be the fire safety.
If there's a fire, people are looking at y'all to be leaders. The quick thing is, am I gonna fight the fire, or are we just gonna get out of the room? Very important. You only have a few seconds to make this decision. It's very important for you to know how to get people out of your room. Some of the labs are small, some of them are big. What's the primary way out? What's the secondary way out? Y'all are the leaders. When something goes wrong, y'all need to step up and be strong, give direction. Fire, for some reason, people are mesmerized by it. They lock up when they see it. So they'll just be kind of staring at it, so you gotta snap their attention and tell them what you want to do. So we're either gonna stay and try to fight it with your CO2 fire extinguisher, or we're gonna leave. We're gonna go outside in a couple minutes, show you what a CO2 fire extinguisher will do with the fire. Let a couple of you work with the fire extinguisher, and kind of you'll see how it's not the easiest thing in the world to do, put out a fire with a CO2 extinguisher, but it can be done. Your evacuation routes. The other thing, calling 911. There's a difference between calling 911 on a university phone and calling 911 on your cell phone. Pretty much everybody carries a cell phone on them, right? The problem, if you call on your cell phone, you're either going to get City of San Marcos or Hays County. Now, that's not a big deal. They're all 911, don't get me wrong. But before you make that call, think about what you're going to say. You need to let them know what you've got and exactly where you are. If you get a dispatcher in Hays County, she's not really going to know the chemistry building where it is on campus. So speak slowly, clearly, tell them, I'm calling from Texas State University, I'm in the chemistry building, we're in room number such and such, there's a, whatever the problem is, but help them help you. Speak clearly, be as short as possible, and then don't hang up. If they have questions, be able to answer their questions, but you gotta help these people get help to you. Obviously, if you're calling, you need help, so help them help you. We talked about the emergency service area. The last thing is, if you decide to leave the building, or or whatever you're gonna do, or if you're gonna evacuate the students and stay, make sure that somebody hits a pull station on the way out. You know, there's not only a problem in your building, in your room, but depending on what happens, it could grow into more rooms. We just want everybody out. So, as you're leaving, there's a red box. As you're leaving, you'll see a red box. As you're leaving the building, just hit the pull station. That'll set off the fire alarm and everybody will evacuate the building. So, with that said, if we'll head outside, we're in the back corner over here on the patio, and we'll do a little firefighting. So what you're going to want to do is grab the fire extinguisher, twist the pin, break that seal, pull it out. It's connected, just let it go. This is your horn. It's very important. You want to position this out and then let it go. There's carbon dioxide in here in liquid form. When it comes out, it's going to get very cold. Don't be holding the horn. You get burned. You'll freeze your hand. Not good. What you're going to do is pull the pin, and then you're going to squeeze and sweep. It's called the pass system. Pull, break the seal, and squeeze and sweep. That's what Vincent did. Okay. So when you're using a CO2 extinguisher, you're not covering the product with anything. You're trying to separate the fire from the fuel. You're pushing the oxygen away. So,
On the outside.
So see, that's why you never turn your back on it. You never know if it's out or not, so you always want to stay looking at it. If it's still in ignition temperature when you back away, as soon as oxygen gets to it, it's going to relight. That's the difference between a dry chemical and a CO2. All that Vincent did was push the oxygen away from it long enough for the fire to go out. There was still fire on the outside edge, so it just relit. So that's why we always tell you, don't put the fire out and turn around and walk away. Keep your eye on the fire and back away from it. Don't ever go to fight a fire if it's going to pin you against an exit. Make sure that you always have a way to get out. Most important. You saw he didn't have very long to fight that fire. It's a small fire extinguisher. Very small fire. Anything big, we get to get professionals in there. Okay? Just give her a new one. Give her a new one. Let her get through the whole thing.
Alright. Alright. Hold it. Hold the pen. And just hold it on the base?
You see how frosty it is?
Yeah, I saw it.
Hold it at the base so you can hit it.
And then just squeeze from the top. That was fun. That was really fun. Yeah, it was a little fun.
So, why don't where was the guy? Okay. What's his name?
I have to do it.
Like adrenaline right now.
So what we're gonna do is, then he's gonna let it back off, so get going. So, yeah.
Way to go, Amanda.
So, they utilize it, so you have liquid in there. So you want to fight the fire, but you don't want to get too close when you're boiling the fire back up and you spill it out.
Okay, so I
So,
go kind of.
well, you want to fight it from the bottom, and push it from the base and push it away. As you start getting on top of it, then you just cover the whole thing. But I don't want you to run up there and just slide it out.
You start from over there, kind of push it, and after pushing it, closer and closer, kind of push it. Remember, there's a leak on the outside.
Okay. So push, and then boom.
Keep an eye on, yeah, you want to stay on top.
Can I pull the?
You want to pull and squeeze, remember? Pull, pin, aim the horn, grab the handle and squeeze.
Okay.
Grab it from the bottom and then you're going to squeeze.
Start right now. Start right now.
Victory!
Did y'all see? He wasn't sweeping the fire. He was just pushing it. So you gotta sweep it. Cover that whole thing. You get the fire away from the fuel. One more person. Okay, so what you do is this will get burned. So you don't want to get too close on it because if you have pressure, you don't want it to boil back under the stand. So you want to start fighting it from a distance. Remember, the big thing is sweep it. Don't do what he did. Just go straight. Sweep it back and forth. You're going to hold the bottom of the container. And then you sweep it. And then as you get on top of it. Good? No, you're doing the whole thing. That's it. That's all we can do is put in there. They're about $135 a piece, so. But hopefully they'll saw the difference. You know, if somebody's worked with extinguishers quite a bit, they haven't, so you kind of saw the difference. But you gotta, if you're gonna do it, do it. Don't play around with it. You don't have a lot of energy. So, don't be afraid. Hey, everybody out, let's go. Do it though, do it. But always respect it. You saw everybody back away from it. Don't turn around, because the next thing you know, it'll take you out. So, any questions?
And you can tell which one's empty, which one's full by the weight. So this is the full one.
That's why it's important to look for the seal. If it has a seal, it's been checked, it's full. If there's no seal, if you come in the lab and you notice your fire extinguisher is missing the seal, contact our office and we'll bring another one.